Before viewing this program, you should have viewed the previous programs on the CX500 Turbo. The earlier programs provide important background information necessary to the complete understanding of this program. So, if you haven't seen these earlier programs, make sure you view them before going further. The CX500 Turbo, Self-Diagnosis and Component Testing, is the fourth program in a series on the CX500 Turbo. In this program, you will learn about diagnosing and testing the computerized fuel injection system and components. You'll see how use of the required tools can help you achieve extremely accurate test results. Plus, you'll get basic knowledge that will help you approach testing and diagnosis with ease and confidence. At the conclusion of this program, you'll be able to describe the pre-start verification procedure for the CX500 Turbo. You'll be able to describe how to test the computerized fuel injection system and fuel system components. Plus, you'll be able to describe ignition system tests and how to test the cold start system. Let's get started with pre-start verification. It's an important process for both the rider and technician. From the moment the key is turned, the Electronic Control Unit, or ECU, scans the computerized fuel injection system, or CFI, to see if everything is operational. By knowing the instrument panel displays, you can assess the condition of the CX500 Turbo before the engine is started. To perform pre-start verification, always put the transmission in the neutral position. Turn the key on and check the panel display during the first 3 seconds. It should look like the display you see here. The oil pressure, neutral, boost indicator, turbo, and fuel system warning lamps should be lit. After 3 seconds, the fuel system warning light should go out, and the boost indicator light should remain on. Any display other than the one shown here means there is a problem somewhere in the CFI system. There are 2 other possible displays for the fuel system warning lamp. One is that the fuel system warning lamp does not come on, and the other is that the lamp comes on and stays on. By the way, the fuel system warning lamp is not a low fuel indicator. It is a warning lamp for the computerized fuel injection system. If the lamp doesn't light, check for a bad bulb by inspecting the ECU display. The W should light for about 1 1/2 seconds after the key is turned on. If it lights and goes out after the prescribed time, the fuel system warning lamp has a bad bulb. If the W does not light and go off, there is a CFI problem. If the fuel system warning lamp remains on after 3 seconds, again there is a problem in the CFI system. Check the LED display on the computer. The LED sequence indicates which systems have failed. You'll see these diagnostic LED displays throughout the program, and a complete list is in the troubleshooting section of the shop manual. The boost indicator gauge also displays important information. With the key on and the engine off, the boost gauge should display 9 bars, 4 bars on either side of the center bar. This display is affected by altitude. The ECU and the pressure sensors are calibrated for sea level. There are 3 possible failure displays. First, only the center bar is lit, and the fuel system warning light does not come on at all. The reason for this display is simple. The engine shutoff switch is in the off position. The second possibility is no display. The bars don't light. Assuming that the gauge works, the problem is that input voltage to the boost indicator is not coming from the PIGN sensor. A good place to check is the white PIGN input connector under the seat. The final problem indication is an overboost display. All bars are lit, and the red end bars flash. This is caused by 2 problems. If the engine is on, and the key is on, it means that there is an open somewhere in the harness between the sensor, spark unit, and the indicator. The second cause of overboost display is a faulty wastegate. This display would come on only when the engine is running. Turbocharger testing is covered in the first full cycle program of the CX500 Turbo series. Remember, when the instrument panel display indicates a failure, always check the computer LED readout for diagnosis. If the problem lies in the CFI system, one or more of the sensors, the computer will show an LED failure readout. And if more than one problem exists, the computer will flash alternating displays of the multiple failures. Okay, let's move on. Testing CFI components can be divided into 4 categories: pressure sensor testing, speed sensor testing, throttle sensor testing, and temperature sensor testing. However, before getting into extensive CFI testing, remove the headlamp fuse and disconnect the brown tail lamp wire to reduce battery drain. A fully charged electrical system is important for accurate test results, so always use a freshly charged battery when testing. Sensor testing on the CX500 Turbo requires special diagnostic tools. They are a digital multimeter, fuel pressure gauge, vacuum pump, pressure pump, special feeler gauge, and a special adapter connector. It is important to preface any testing of the CFI system with a close check of the connectors. Make sure that they snap firmly together. With the key on, wiggle the connectors while watching the computer LED to check for bad connections. Also, always clear the ECU memory by switching the key on and off each time you recheck the LED readout. Next, remove the sensor hoses and connect a vacuum pump to each one to ensure that there are no leaks. The hoses must hold a vacuum for the system to operate properly. If the hoses and connections are okay, you'll then check the input-output voltage at the sensors to see if they are within specification. You'll measure the input voltage and output voltage at specified points. The chart shows the voltage specifications for all the sensors. For our test example, we'll use the PB sensor. All pressure sensors are tested exactly the same way. The only exception is the PIGN sensor. The PIGN has reverse polarity and is hooked up for testing in the opposite manner. See the troubleshooting section of the shop manual for details. Hook up the special adapter to the PB sensor connector and the main wiring harness. Attach the multimeter's red probe to the adapter's pink lead, and the black meter probe goes to the adapter's green lead. Set the multimeter to the 20-volt DC scale and turn on the ignition. The voltage reading should be between 4.75 and 5.25 volts DC. Sensors PB, P1, and P2 should have the same input voltage. If the input voltage does not meet spec, check for battery voltage at terminals 1 and 2 of the ECU coupler. If voltage is correct at the ECU and incorrect at the sensor, replace the ECU and retest.